Hello again. Here's another math lesson for the students at Marion Mix Elementary School in Elk Grove, California. I'm Mr. Ohama, and we're going to be doing multiplying by two-digit numbers. Today it goes with Go Math Lesson 1.7, and your learning intention is that you can multiply these things using the traditional algorithm. So that's what I'm going to be demonstrating today, and our success criteria is, did you estimate? Did you estimate first and see if your product is going to be a reasonable answer? And did you use the traditional algorithm? We know that there's multiple ways to multiply. All right, skills we're going to need is, you need to know your basic facts. You need to know 8 times 7 equals 56, and so on. Because otherwise you're going to be thinking about that too much and not where to write the numbers. In this lesson, you really need to write the numbers in the right spot. And then place value is another skill you need for this, because we're going to be talking about multiplying the ones and the tens and the hundreds and things like that. And you need to kind of know where those things are. And then the vocabulary is product. So when I say product, that is the answer to the multiplication problem. All right, here's some notes. Please write them down, pause the video, and then begin again after you have them down. And what we're doing is we're just going to round both numbers before we estimate. Wow, look at this. Here is the first two example problems. All right, we have 28 times 18, and we're going to estimate these first and then multiply them. So I'm just going to write above them because I don't have any room off to the right. 30. The 28 is estimated to a 30, and then the 18 is close to a 20. So 20 times 30 is 3 times 2 with 1, 2 zeros on it. So my estimate is it's going to be around 600. Now when I set this up, I will set it up as, let's see, I think I'll start here. 28 and multiply that times 18, and this is the traditional algorithm, so we're going to be multiplying the ones times the ones and the ones times the tens, then the tens times the ones, then the tens times the tens. All right, so for some reason it's difficult to say. All right, now starting off the first part here, we have 8 times 8, and that's 64. And that's like 4 in the ones place and 6 in the tens place, right? So we write the 4 down here with all the ones and the 6 up here with the tens, right? So now I'm going to be multiplying the 8 times 2 tens. 8 ones times 2 tens is 8 times 2 is 16, plus 6 more tens, right, is 22 tens. And there's 2 available spots to write the 22 in right there. So my first line should be 224. 8 times 28 is 224. Now when I'm finished with multiplying that first number, I always just kind of cross it off, so I don't even look at it anymore. And after I cross it out, I realize the next digit over that I'm multiplying is the tens place, right? So anytime we multiply something by a 10, we always just put a 0 on the end of it. So we put the 0 down first to hold the place before we start multiplying. All right, I've already used that one too, and I'm going to get rid of it. And then I'm going to multiply. So we got 10 times 8, but really we're thinking 1 times 8, right? But since we're writing it in the tens place, it's going to be 8 tens. But we kind of fool ourselves into just saying it's 1 times 8, and that's fine. 1 times 8 in this next spot is 8. And then 1 times 2 is in the next available spot, which is in the hundreds place. So 110 times 2 tens is 200s, really. So 1 times 28, 28 with a 0 on it, good. And then you have to add both these partial products together. So 4 plus 0 is 4 ones. 2 plus 8 is 10. And here's where this traditional algorithm takes a little bit of knowledge. You have to kind of squeeze in sometimes when you regroup and carry the 1 over to the next place value. You have to kind of squeeze it in. So 8 times 2 is 10. The 10 is written up there, the 0 on the bottom. And then 1 plus 2 plus 2 equals 5. All right, so our estimate was 600, and our actual product was 504. Now that's close enough for this one. if we got like 5,000, then our estimate would be so different that we must have made a mistake. But in this one, we're going to say, hey, I think we did it okay. All right, the next one is 126 times 52, and we're going to be lining it up to the right here, using the same traditional algorithm. Okay, what did I forget? I forgot to multiply here. So I'm going to be multiplying, I forgot to estimate. All right, so I'm going to be estimating to rounding it to the highest digit. So I look to the right, it's a 2, so I round that down. 100 times 50, because 52 is closer to 50 than it is to 60. And then 1 times 5 is the simple fact, right? 1 times 5 with 1, 2, 3 zeros on it. 1, 2, 3 zeros. Now it's going to be around 5,000. But if you take a look at these numbers, you're going to realize the number that we get for the actual product is going to be way over 5,000, because 126 is over 100 and 52 is over our estimate of 50. So our answer should be more than 5,000 on this one. Let's find out what it really is. All right, by the way, you should be writing these problems down and solving them as I solve them, so you have 2 good models of how to do this. This isn't just watch, right? You're actually working during this time. All right, perfect. All right, 2 times 6 is the first thing. That's 2 ones times 6 ones. That is 12 ones, and so the 2 goes down below and the 1 goes up in the tens column. Now I'm on to the next digit, 2 times 2, which is 4, and then add the 1, that's 5. And then off to the last digit, 2 ones times the hundreds. 2 times 1 is 2, 2 hundreds. All right, then cross it out because I'm finished with it. Put my placeholder down here because I'm multiplying by the tens place now. And I'm going to cross out the one up here that I already carried. Then I start with tens, right? 5 times 6 is 30. Right, and the 3 goes over the next place. And it's kind of funny that you write a 3 up here and a 0 down below it. But that is actually the case. That's what we're doing. And that's why the traditional algorithm is so confusing sometimes. But I just say that if I'm multiplying this ones place here, after I'm finished with that, the next digit over is where the 3 is going to go. And the 0 is just going to go in the next place that I had available, which is here. Right now I'm on the tens times the tens here, so 5 times 2 is 10, plus 3 is 13, and again it's just over the next digit. And then 5 times 1 is 5, plus 1 equals 6. And after you multiply, we're going to add those partial products. So 2 plus 0 is 2, 5 plus 0 is 5, 2 plus 3 is 5, and 6. So our actual product is 6,552. It's close enough to the estimate, and we already knew, because these 2 actual numbers were higher than the estimate, that our actual product was going to be higher than the estimate. So this one seems reasonable to me. All right, so here's a common mistake, multiplying like you add. So let me give you an example. This is what a lot of people, they try to do. They see 67 and they're going to multiply that by 13. Instead of multiplying the 3 times the 2, then the 3 times the 6, then the 1 times the 2, then the 1 times the 6, they'll just do the lazy way, which is 3 times 2 is 6, 1 times 6 is 6. The end. I'm done, right? But this has to seem kind of ridiculous to you, right? If I take 62 and I add that 13 times, I'm really only going to get 66. This is the wrong way to do it. All right, so back the video up and watch the right way if you would like. All right, work on page 33 with 90% accuracy, and you will have successfully completed this lesson. Good luck.